Hi, welcome everyone. Welcome to this last week of Systems at Scale Spring Edition 2022. We are now live with our panelists. So let me introduce the panelists. All right, I can see everybody. So let me start with a quick round table of a bit of introduction. So I'll start with myself. My name is Francois. So I'm currently located in Bellevue. This is in Washington State. Currently, the weather is actually nice today, so it's great. So I'll move to Yuri next.
Hey, thanks so much for having me. I'm an SRE at Google Cloud. I'm based in San Francisco, and where it's somewhere in the mid 60s and sunny today.
Great. All right, I'll move to Christopher.
Hey, my name's Chris. I'm a production engineer here at Meta, and I'm in Seattle, and it is not currently raining.
Yeah, that's great. All right, I'll move to Osama and Amr.
Hey, I'm Osama. I work for Microsoft Cognitive Services, and we're located in California in Silicon Valley, and it's quite warm and it's sunny today.
All right, I'll move to. Oh, yeah, Amr.
Sorry. I'm Amr, software engineer at Microsoft. Same as Osama, we're in the same location.
Great. I'll move to Jay.
Me? Oh,
yes.
I'm Jie. I'm a software engineer at Meta. I'm based at Bellevue too. And now it's getting cloudy. It was sunny a minute ago.
All right, thank you. I'll move to Jason and Arushi.
Hi, I'm Jason. I'm also in Bellevue, and we have this nice interior room, so I will rely on Francois for our weather report.
All right.
I'm Arushi. I'm a software engineer at Meta, and we're like 3 floors down from Francois, and it's nice and warm here.
Great. So we'll get going with the live question. So let's see. I'll start with Yuri. We had a question, related to metrics that we usually see in the hardware world. So the question is, why are you not talking about metrics like MTTR or MTBF?
That is an excellent question. And what we've really found is that we've actually published an entire paper on this, but essentially there's so much variation between different incidents and different kinds of incidents that attempting to use the mean of these metrics has shown us that we're just not able to make any good engineering decisions using these metrics. I'll have to find the link to the paper that we've published on this. So there's absolutely value in looking at a given incident and saying, what could we have done to detect it faster, to triage faster, to mitigate it faster. But when we start to look at this information across incidents, we just see so much variation in the problems that attempting to kind of do any kind of this analysis on the metrics over time has just not proven valuable at all. And we've like I said, we published a paper on this that you should be able to find. So we're really not using mean time to repair or mean time between failures for any decision making moving forward.
Great, thank you. So let's move to vacuum testing. First question related to Belljar. So if Belljar does focus on first up relationship, like the first level of dependencies, how does it help address like the multi-op or like the transient dependency? How do we deal with this?
I can take that. So one of the challenges that we find when we talk about dependency management in a large stack like we have at Meta is that if you require everybody to understand the entire tree of dependencies, even in infrastructure low in the stack, you're effectively asking everyone who works on those systems to understand how the entire universe of infrastructure works. So for us to impose that expectations on teams and say, in a tool like Belljar, you need to express your entire transitive dependency set, is kind of asking them to do the impossible, right? No one person understands that entire tree. So what we do is we bound them to saying, you only need to express your first hop dependencies, the relationships that your system makes with other pieces of infra. And then if we can expand the coverage of testing that we do with Beljar to all of those first hop dependencies. Then we can ask the same question of them. And then we can move to their first hop dependencies and rinse and repeat. And so the approach here is not to require that a service owner or the owner of a daemon that runs on our hosts understands all of these transitive relationships. We're going to try to assemble that graph from a collection of little pieces, little puzzle pieces that comprise the whole. And so it's not actually that with a single Beljar test, you're going to be able to detect transitive dependency cycles, for instance, but with good coverage across the bottom part of our infra stack, we're able to identify those transitive cycles as we fit these puzzle pieces together.
All right. Let's move to Southpaw and something almost similar to dependency. So let's do this. So you are literally putting all your tokens in one basket. What happens if the priority queue goes down? Or if one of the dependency of this priority queues goes down?
Yeah, that's a very good question, actually. So Southpaw is able to detect, so it detects this failure when it happens in milliseconds, and then falls back to traditional load balancing. And also, after the queue gets up, Southpaw is able to reconnect and start using the tokens, and the tokens actually gets reconciled after the queue is up again, and then they get reused eventually.
Great. So moving to all, in the talk, you talk a lot about the policy and how we can control the flow of data. So can you describe what policy combination are used in practice and what type of workloads used in each combination?
So as mentioned in the talk, we have a large number of policy combinations in use in production at any given point. The most basic functionality being, location aware, which is sort of the baseline that we use for almost everybody. When we find specialized customers, people try and optimize for their use case, either using emulation or also talking to them and sort of understanding what their biggest constraint is in terms of resources that they want to use on the box. One of the examples in the talk was sharing buffers with the client where they're not making any changes. This is to optimize how much memory they have to give. Another common case is putting limits on how many outflows there can be on a given box, because we don't want to take down the network just by doing peer-to-peer. So that's a very common case as well. Jason, are there other specific ones you want to point out?
Well, I could talk about the caching policies, because that's another set of policies. So generally LRU is where we start, because it's pretty hard to beat LRU. But often we find that we need to customize for the hotness or the coldness of data and handle hot and cold data differently. And a policy that tries to spread cache copies around to make sure that there's a few copies cached within the entire set of peers often is very effective for customers that have a really large working set, because it allows them to have a much larger cache while the peers are working collectively. So those are some of the things that we do. And then when you take the space of caching policies and the space of selection policies and you multiply them together, you get kind of this exponential combination, which is why we have the numbers that we talked about.
Okay, great. We'll come back to policy a little bit later. So let's go back to Yuri. Question is the following: how do SLOs and error budget factor into all this? How do you use them to identify and evaluate options?
Another great question. So I think where error budgets really come into this. So remember, the talk is about making engineering decisions and prioritizing engineering decisions in an effort to get better at managing incidents, and specifically in reducing incident impact. So the impact to error budget is how you would actually do the prioritization exercise, right? Because you would look at an incident and you would say, during the incident, we burned this much of our error budget. During the detection phase, we burned this much of it. During the mitigation phase, we burned this additional amount. So based on where most of your error budget burn is happening, basically, which of these phases you're spending the most time in, quite simply, that's where you would start to focus in terms of prioritization your efforts. Now, the obvious thing also is the actual alerts. The thing that they use to detect that an incident is happening would be based on air budget burn, knowing that your users are impacted, users are suffering. But I think the direct answer to the question is you'll be using air budget specifically to have your alerts triggered, letting you know that you're burning air budget, that the SLO is threatened. And then when you're working through the prioritization exercise, you would prioritize things based on how much impact to air budget burn you think they could potentially have.
Like a very related question. Have you ever used these error budget to go back and reprioritize product roadmap related to the area?
It's not something that I personally have an experience with, but I could certainly see, probably in a more broader sense, we would use learnings from incidents, action items that we would identify in their retrospectives to feed back into the engineering work. That would obviously be informed by the roadmap. So in my experience, roadmaps are typically covering the user-facing features, but the engineering work isn't just on the roadmap. The engineering work has to cover the features as well as the reliability, scalability, security, all the other horizontal stuff as well. And so you would take learnings from incidents, including action items you would identify in retrospectives, and feed that into the engineering work.
Great, thank you. All right, let's move back in testing. So let's talk about the recovery graph. So you mentioned that the recovery graph can look quite different from the graph of a system dependency during runtime. So basically, like at runtime, there's something, during recovery, there's something else. Do you have some example of these?
Jay, do you want to talk about that?
Okay. So for example, for Zookeeper, while you are recover or bring up Zookeeper jobs, you need the thing like the backup service we have. You need to get your code, your backup data, then you can recover. But these are not required when the jobs are running in a stable state.
Okay. Yeah, I can add a little bit more to that too. The infrastructure that we need to just start those containers that Zookeeper is going to run in also is only called or invoked at the time that we're starting a recovery process. So Zookeeper is actually really good at not talking to anything other than other Zookeepers, but getting to the point where we can provision certificates in the right way into the container, make sure that the container is composed of the packages that it needs to have the blobs that it's going to run. All of those preliminary steps are things that service owners tend not to think too much about because it just happens magically for them. So we don't force them to think about those requirements by expanding the scope to recovery. Often they'll think, oh, my recovery just requires other Zookeepers and nothing else, which isn't the case.
Okay, great. Let's move to Southpaw. We spoke a lot about the token and the way you manage them and you assign priority to them. Can token priority be figured out by other condition? Like something like maybe like you have some case like, use case priority, cost, CapEx, or?
Yeah, I mean, the concept of priority itself can abstract any underlying metric, really. We just, in our use case, we chose the current concurrent requests on a particular service instance. In theory, it is quite possible to tie up the priority to something like current conditions on the container or the actual hosting node. For example, you can wire it up to a C group PSI current reading. And if you see that resource pressure is on the rise, you can dynamically start reducing the priority of the tokens that you're issuing such that you slowly divert requests away from you as long as you are above the average of everyone else in the cluster. We don't have a specific use case for this because we usually didn't have to go to that extent, but there's nothing preventing us from doing that as long as you can represent your load or you present your current load conditions using a one-dimensional metric, which is the priority, then there's no reason why it should not work.
Right. So let's go back to all for a little bit and let's talk about policy again. So during the talk, usually you have like very extensive way of creating policies and you can support all sorts of things. So how do you help users or customers figure out what they need?
So when we started out, we had few policies and we were doing this sort of manually by talking to customers, sort of seeing what seemed to fit as a first good approximation and then rolling it out and tweaking as we went. Since then, we've built an emulator, which we talk about in the talk, but it sort of takes a snapshot of the customer's traffic as requests are coming into our system, saves that as a trace, and then basically spins up the tracker, but then also emulated peers that basically take that trace, run it, and issue requests to the tracker. We then have the tracker run through different policies and different policy parameters to sort of see what is the hit rate we would get if we were to run with those settings for a given trace that we've gotten. This helps onboarding quite a bit because we can have a better sense of what would be a better policy for this customer. For the most part, this is currently done by us and not by the user. So, we run the emulation, we sort of analyze the results and make sure that we're not doing anything crazy in the emulation, and then go back to them and say, hey, here's how much we think you need to give us in terms of capacity in your boxes, such that you can get peer-to-peer sharing. The other thing that we do is also run this regularly for all the users on the system, such that we can see if something has changed in their traffic, if we need to change the policy, or if we've added a new policy type that didn't exist when they got onboarded, and they should maybe move to that. So that's been our approach for the most part in figuring this out. There is some. We also have some customers who, like the 3 systems that we talk about that use our system, that are like big systems in themselves, and we do have like on calls of their systems who know that Hedwig could be useful for certain customers that have this hot traffic. So that's another way we get this funnel of customers. And because they're coming from a certain system, we can have some hunches about what would work for them.
Okay. All right, let's move back to Yuri. Let's talk a bit about stuff around team culture. And this is a question we just got, so it's really fresh. So is there a scenario like sometimes at Google where the SRE team by itself cannot figure out, cannot mitigate a problem or something, and you need to actually involve like the engineering team or the product team and so on? And if that's probably happening, if so, do you guys have a process that you follow there about like escalation path and so on?
Yeah, excellent question. So I do want to, so before I actually answer the real question, I do want to differentiate between what we consider to be mitigation versus the kinds of scenarios where you might need to involve the development team. To us, we think about mitigation as sort of the fastest thing we can do that'll restore the service back to a known good state. So even in a scenario where we think the problem may have to do with the source, with the code of the application, we think we pushed out a bad version. The mitigation to that is not to fix the code. The mitigation is to roll it back to a good known good to a known good version. And so because for most of our services, we have this set of mitigations available. So it'd be things like provisioning, extra capacity for unexpected load, routing traffic to a different data center to deal with traffic spikes or to deal with local network outages, for example. Or to roll back a configuration or a code change that we think may have broken the service. None of these things require working with the service development team, right? There could be, cases where we may not be certain, right? We think that maybe the latest rollout may be broken, but it could be something else. I can't think of an exact scenario where we would need to escalate to development during an incident. But the answer is like, yes, sometimes that does happen. And it will typically happen in one of two ways. For teams where there's a sort of a good relationship, the engineering team that the SRE team is partnering with will actually have its own on-call rotation, where SREs, even though if they can't resolve the problem themselves, they will actually page development, and someone from that on-call rotation will respond and pick it up. Typically that happens for services where, like we know that that's necessary for whatever reason, typically just like through some hard-earned experience. If that's not the case, then we, if the development team is not participating in the on-call rotation or is not staffing their own on-call rotation, then we would try to get a hold of someone sort of kind of in the best effort ability, right? We would ping a chat channel or something like that and hope that we get a hold of someone. But like, if you're really dealing with something in the middle of the night where like the service is burning, I mean, an overwhelming majority of the time, right? We're talking like 99% or more than 99% of the time, one of the mitigation techniques that we as SREs have available to us should be sufficient to restore the service to a known good state, or perhaps put it into some kind of a maintenance thing where we could basically stop throwing errors and just return a, everything's okay, but we don't have any data for you kind of response.
Yeah. Okay, thank you. So let's move back to vacuum testing. Let's see. So let's talk a bit about fault injection. So you spoke about like, fault injection, and then you create the mode. And so how does that work?
I can talk to that. It's kind of like a reverse fault injection. So for us, if you don't say anything, everything is disabled, everything is blocked. And then you only explicitly allow a network port or allow a specific service. So that's how we create the mode. We push our fault injection team really hard to provide the primitives we need to create this mode to like what exactly is allowed. It's allowed. In the experiment environment, what is allowed.
Great.
Do you have anything to add?
No, I don't think so. Maybe the only thing I would add is that translating between what a service owner or someone who's constructing a bell jar test wants to express into the low-level primitives that we can use to disrupt the machines that are part of the experiment is sometimes tricky business, because you might want to express, hey, I want to allow access to some service that's running in the data centers. And that service doesn't come with like a static set of network addresses, for instance, but the tools that we have to apply that moat really works at the fundamental operating system level, right? So we're talking about socket addresses and things like that. So, and those remote services, they might move, to other machines or other addresses in the middle of that experiment. So doing that translation in a dynamic way is one of the many ways in which we ask our pretty awesome fault injection team to accommodate our needs.
Good. All right, let's move back to SALPA. Let's talk a little bit about the open source component. So the SALPA requires Kubernetes, or can it work on its own?
That's a good question. So SALPA does not have any dependency on Kubernetes. It's just that we actually, and Microsoft Space Services, we utilize Kubernetes, and hence we run SALPA on Kubernetes. But SALPA is independent and doesn't have any dependency on Kubernetes. And in fact, it's actually cross-platform, so you can even like run it on different operating systems. We here in Microsoft Speech, we run it on Linux, and this is where like most of the testing and things happen. But you can basically run it on different operating systems as well.
Okay. On the same style of question, does it work with like, local reverse proxy like Envoy, Istio, and so on?
Take that.
Yeah, I can answer that. So today it does not, because it has its own mind about load balancing and how it takes these kind of decisions. And the majority of reverse proxies like Envoy or Linkerd, which are the most common ones, are very specific about the way they want load balancing specifically to be handled. But having said that, we realize that mesh services are becoming an integrated part of any modern cluster. So we have experimental support for Envoy and Istio integration, where we let Envoy do what it does best, which is forwarding, and we let Southpaw only handle the load balancing part. This way, you sort of get the best of both worlds. You have your configurability and control plane from Istio, and you have the super high performance of forwarding from Envoy, but only load balancing is performed by Southpaw.
Great. Okay, so I'm going to do a little time check. So we're getting close to noon Pacific time. So I'm going to go and take on 2 additional questions. So question is for all. What's the most important criteria in selecting a peer from which you download the chunk that you need at a given point in time?
It's a good question. We talked about this a little bit when Arushi talked about policies. So many of our policies are location aware, and so we try and construct a topology where we select peers that are nearby. So essentially, the communication is set up so when we can see, very, very large numbers of hosts downloading the same content at the same time. Ideally, all the hosts within the same rack should be downloading from each other, and one should be fetching from outside the rack. And then you can walk up to the cluster level, to the data center level, to the region level. Beyond that, it gets very application specific as to which peers you want to select. But that one is almost always important.
Yeah, I think that's right. I think the only other criteria that becomes really important is not overloading a specific peer and making that the source for everybody. So location obviously helps with that implicitly, but we try as much as possible to spread the load out so that one peer is not feeding into too many other peers and becoming a single point, both as a bottleneck and as a failure point. So we try and make the tree as spread out as possible.
Great. So I'm going to move to one last question for Yuri. Around run books, any special insight or process on how we keep these things up to date? Because they're all good on version 1 of the system, but as soon as we evolve it, we all been waking up in the middle of the night where the run book is halfway correct.
Yeah, absolutely correct. And you absolutely do have to maintain them. So the way that we ensure run books are up to date is essentially in 2 ways. The first one is in the exact scenario you're talking about. So during an incident, if we notice that a run book is not up to date, whether that's at 3 in the morning or 3 in the afternoon, we absolutely make a note of that. And that'll be one of the action items that we'll note in the retrospective. And so that becomes an engineering task that has to be taken care of, right? As an action item coming out of it is, the run book's out of date, so we need to go and update that. So we make sure that we prioritize that sort of thing. The second way we do that is through a more proactive fashion, which is essentially through incident drills. So we kind of do these in a number of different flavors. The easiest one to execute is essentially a theoretical, like tabletop exercise. You may have heard of them referred to as a wheel of misfortune, where we essentially kind of pick an unsuspecting victim and we say, hey, this alert just fired. What do you do? And they just kind of walk through their triage and mitigation process, and they'll try to follow the run book. And if they see that the run book is out of date or doesn't make sense to them even, or just needs to be clarified or made simpler perhaps to understand, then again, that's just an opportunity to fix those kinds of things and make sure that they're up to date. So it's really through the combination of incident drills, practicing, and through making sure that if we do detect any inconsistencies or inaccuracies during real incidents, that we take care of those as well.
Great, thank you. So thank you, speakers and presenter for being here this week. Thank you to the audience for following us for 3 weeks in a row. We're really sorry for the technical difficulties we had on the first week. So It's great that people were able to join again today. And that will be a wrap up for this edition of Systems at Scale. And I think we will see you guys all in June for our next edition. So thank you. Thank you, everybody.